We'll proceed in flux calculation in calculus. As I always talk that we have seen curl calculation where vector field has line integral. If I have a vector field is nothing but algebraic vector. A vector has components. Each component is algebraic function over independent variable and this is called vector field. Okay, so if I have a vector field, then can I multiply this vector field with a line? Why I need this multiplication? Consider the vector field what I have is a force vector. Force vector field, a force can be, as I say, force can be 2i plus 3j. If this is x-axis and this is y-axis, this is x-axis and this is y-axis. Now there is a force like this 2i plus 3j means force effective component along x-axis is 2i. Force effective component along y-axis is 3j. Okay. Now this force now can be x plus yi plus x plus sine y j. If that is the case, earlier the first component was 2, second component was 3. Now first component is x plus y and second component is x plus sine y, x plus yi plus x plus sine y j. So here it would change. If I keep changing x and y, every moment it will give me new vectors. So this is called vector factory function which generates new vector or vector field. If I have a vector whose components are algebraic functions, then it is called vector field. Now if this is a force vector and I need to displace, if there is a force vector 2i plus 3j or x 2i plus 3j or x plus yi plus x plus sine yj is the force and I need displacement of an item from here to here. Because of the force, item is getting displaced from here to here along x-axis. What is the work done that force is doing when it is displacing an item from point A to point B? If that is the displacement A to B, then what is the, if force was along this, then force into B minus A is the work done. When force is like this and I want work done by the force along x-axis, then what is the effective force along x-axis? 2i plus 3j, then it is 2. 2 along x-axis. X plus yi plus x plus sine yj, then along x-axis the effective component of the force is x plus y. Can you see it? That even though the it is along x-axis but it is x plus y means now y is 0 if it is along x-axis, but if it is parallel to x-axis then the force is different even though it is along the x-axis. So the force is dependent upon independent variable x and y along x-axis, whatever it is. Now what is the work done by the force from point A to B? Then it is x plus y into b minus a. If y is 0, then x into bracket b minus a. That is the work done. So force multiplied by the displacement line is the work done. This is also called line integral if I take integral calculus. Capital F vector dot d r vector, where r is the line through which the item is getting displaced, integration from a to b. This is called line integration. Similarly, if I have a vector field and I am trying to calculate surface integral, if I have a vector field and I am trying to calculate surface integral, okay. So if I have a vector field, I am trying to calculate surface integral. Okay, I understand that if vector field is velocity field, if vector field is force field, then line integral gives the net work done. What about if vector field is velocity field? Means someone would ask, right? Means what is the implication that vector field surface integral makes sense in real life? If vector field is velocity vector, then surface integral means vector field multiplied by the surface. Integration means multiplication. Simple. Algebraic multiplication leads to integration because net integration will come as algebraic equation only. The direct algebraic multiplication will not work. If that is the case, then we have now that we have kind of surface integral of vector field along the surface means vector field multiplied by the surface. That is a surface integral. If I have a velocity vector, like consider there is a water flow, and if I place my hand, consider a river is flowing with a velocity, and I insert my hand in this is river that is flowing. I insert my hand inside the river. Now you tell me that how much is the water that is passing through, how much is the water that is passing through my hand. Okay, so nothing is passing through my hand. Consider this is the item that I placed inside the river. Now you tell me amount of the water that is passing through this surface, this hole per second. What is the volume of the water that is passing through this hole if I place it into river? If that is the case, then what is the velocity of the water? Velocity of the water is x meter per second. What is the area of this shape? This then area is y meter square. Then x into y square meter cube per second is the water that is passing through it. What happened? If there is a velocity vector and there is a area, then velocity into area gives me the net volume of the water that is coming out of the surface. It is also called flux, flux of the velocity vector through the surface, flux of the velocity vector through the surface, or the net flow of the velocity vector through the surface. This is flux. We are in discussion for the flux. If I have a vector field and vector field is passing through a surface, then what is the net flux of the vector field along this surface? What is the net volume that is coming per second from this surface? That is flux. If the velocity is v and area is a, it is v into a, but velocity has to be in direction of the area vector. This is if this is the area, then its vector is like this. If this is the area, then vector is perpendicular to this. If this is the area, then vector is perpendicular to it. This is area vector. This proves that the vector field direction must be in direction of the area vector. Then only we can multiply. Otherwise, we have to do dot product. If the velocity vector is like this and I'm trying to how much is the flux that is through this surface, then velocity vector dot product with the direction of the area vector and then multiplied by the area magnitude. So capital F dot area vector. Capital F is the velocity vector. Capital F dot area vector. Now, if I talk in kind of integral calculus, where capital F is algebraic function, area is not flat, area is like this. In that way, areas normal are different at different positions. I cannot take a single normal. If that is the case, then capital F dot small d, dA vector, that is the flux. Capital F dot dA vector integral along the surface. So capital F vector dot small dA vector. What is A vector? A vector, if it is a flat surface, I can say what is A vector. But if it is surface is not flat, surface is like this, any shape, then what is A vector? that is in question. So please watch last video, and we have talked about calculation of a vector. If you want area vector, like, okay, if you want area vector, consider this is a sphere. Okay, so I have a 3D shape. I have a 3D shape, and now everywhere area vector is different. How I can calculate area vector as algebra, where this is xy plane, this is x axis, this is y axis, this is z axis, this is xy plane. Over xy plane, I have a kind of 3D model. And area vector, everywhere area vector is perpendicular to the surface, and it is like that. How I can calculate area vector? Now what we have seen, how we can calculate area vector is nothing but minus. Now if what is the independent component? This is x axis, this is y axis. Then independent component is x axis, y axis, or rather I say independent component is xy plane. If independent component is xy plane, then what is dependent component? Z, vertical component, is dependent upon xy through algebraic formula. Consider, consider this is the kind of a, this is model, and its algebraic equation, that is z equal to or fxy equal to something. So the every point, what is the z value? Z is nothing but function over x comma y. Now we have seen, if that is the case, I can take out a small area strip from somewhere, small area strip. That area is delta A, very small. It is so small that if I take it out, it will be like a flat, it will be like a rectangular flat surface. I zoomed it. I took out very small portion from it, and then I zoomed it. It become like this. If that is the case, if that is the case, then we saw that any, if this is xy plane, and I have any point x comma y, if this is xy, if this is xy plane, if this is xy plane, I have any point x comma y, then fxy is this point. If that is true, if fxy is this point, or this point, or if this is xy, if this is xy plane and there is any point x comma y, this point is x comma y comma fxy. Fxy is the vertical. Now if I draw a position vector from origin here, fxy consider z, then it is xi plus yj plus zk. If this is a position vector, then gradient of this position vector, gradient I have to calculate with independent component. If I calculate gradient with x-axis, then it is perpendicular to the position vector, but it is along x-axis. This is x-axis, this is y-axis. If I, this is the position vector, if I calculate gradient along y-axis, it will be perpendicular to this, but it is along y-axis. That is, if I consider position vector as p, then dp by dx, dp by dy. So one is xi plus yj plus zk, dp by dx is I plus dz by dxk, dp by dy is j plus dz by dy k. Now if I have one vector like this and another vector like this, then what is this area? If I have one vector along x-axis, that is dp by dx, or one vector along y-axis, that is dp by dy, then what is the area? That is cross product of dp by dx and dp by dy. If I have two vectors and if I want area between this vector, then I have to take cross product. So dp by dx cross dp by dy. Now I have got area vector. But since area vector, if that is the area vector, then every moment, okay, so what we have got? Area vector. So if I have got area vector, then dp by dx, okay, so dp by d, now we have area vector as dp by dx. dp by dx, if I take any position here, dp by dx is like this, dp by dy like, if I took cross product, I get the area at that position, and that direction will be perpendicular to this, whatever. If I am getting area vector, that is dp by dx cross dp by dy, but this area is velocity area, means I want position area, not the velocity area. dp by dx, one differentiation I did. So if p is the displacement, the dp by dx is velocity vector. So I got the area vector but as velocity vector. If I want the area back to displacement vector, then I have to do integration back. So dp by dx cross product dp by dy, and then integrate it along the xy plane dx dy. If you do so, then you are getting area vector. Okay, area vector. Now you are getting every place area vector will be different because it is an algebra. If that is the case, then what we got, dp by dx cross product dp by dy, that is the velocity area vector, dx dy if it Cartesian coordinate. So that is the area vector we see as far as mathematics is concerned. So dp by dx is I plus dz by dx k, dp by dy is j plus dz by dx dy k. If I do cross product, it comes as minus dz by dx I minus dz by dx dy j plus k, and then d area vector. Then we, through this area vector calculation, we calculated kind of the, if this is the area, then we did one example in the past video. Anyway, now if I have area vector, then what is the actual area? Later we will see this area vector for the cylindrical coordinate and for the spherical coordinate also. Okay, but let's proceed. Means we have done something. If I have area vector, that is minus dz by dx I minus dz by dy j plus k d dx d plus k dxy plane, that is dx into dy. Because in Cartesian coordinate, if I take xy plane, and then if I dA means if I take any small area, that is dx dy. If this is the area vector at any point, if I have area vector any point, then what is the actual area? Simple area, then magnitude of this. So minus dz by dx I vector minus dz by dy j vector plus k vector, if I calculate its magnitude, it will come as a square root of dz by dx whole square plus dz by dy whole square plus 1 dx dy or dxy plane. That is the area of a surface. Now integral over full surface will give me the full surface area. Knowingly, unknowingly, we are in calculation of we started with the flux calculation, right? Flux calculation is capital F vector dot d area vector. Now d area vector is nothing but minus dz by dxi minus dz by dyj plus k dx dy in Cartesian coordinate. Capital F vector dot with this. If you do this dot, we will land up in an algebraic equation, integration with dx dy and integration over the full surface, for which we are trying to calculate the flux. We will do more example in this. But when kind of somehow we landed up in calculating the area vector, if I calculate the magnitude of the area vector, it gives me the surface area. If that is the case, and if I consider this as a sphere, then what is the surface area of a sphere? Consider this a sphere is centered at the origin. Consider this sphere is centered at the origin. Okay. If this sphere is centered at the origin, consider this sphere is centered at the origin. Then what is its surface area? Okay, so this is the question. If this sphere is centered at the origin, then what is its surface area? Okay, now if it is centered at the origin, then xy plane is crossing this at the center, equatorial. If it is north pole and south pole, this is equatorial. Then xy plane is crossing this at the equatorial, upper half, lower half. Now this is x-axis, this is y-axis, this is z-axis. If that is the case, then what is the equation of a sphere? Equation of a sphere is x square plus y square plus z square equal to a square, where x and y are independent component and z is dependent upon x and y. All three are not independent. Then z equal to square root of a square minus x square minus y square. dz by dx is minus x divided by square root of a square minus x square minus y square. dz by dy is minus y square root of a square minus x square minus y square. Then what is the area? Area is nothing but the magnitude of area vector, integral over full surface. So area vector was minus dz by dxi minus dz by dy j plus k dx dy if it is Cartesian coordinate xy plane. If that is the case, dA not vector. Okay, dA vector is minus dz by dxi minus dz by dy k j plus k dA. If this vector, if I calculate this, if this vector magnitude, if I take, okay, and then this vector what we have seen now, this will be magnitude of this multiplied by unit vector. If unit vector, if I take that side, then it becomes area vector back. But anyway, I am not interested in now direction, because we are interested in magnitude. We are calculating the surface area. What is magnitude? That is dz by dx whole square plus dz by dy whole square plus 1 square root, and d area, d small d integration over area, that is xy plane, integration over full surface. Okay, if I take xy plane, then it is minus a, x axis is minus a to a, y is minus a to a. If I calculate this, then we will land up in calculating the upper hemisphere surface area. Down we are not calculating, because we have taken everything in x-axis and y-axis. X-axis and y-axis, then z is up from the xy plane. Now let's calculate. This is our calculation. You may not find anywhere. Anyway, then if I am calculating dz by dx whole square plus dz by dy whole square plus 1 square root dx dy, dz by dx is minus x, a square root of a square minus x square minus y square. Then full will become minus x square by square root of square, right? dz by dx whole square. So x square divided by a square minus x square minus y square plus y square divided by a square minus x square minus y square plus 1. If I settle it down, it will become a by square root of a square minus x square minus y square dx dy, x minus a to a, y minus a to a. Now calculate x equal to a square root of a square minus y square. When we are integrating with dx first, I'll consider y as constant. Let's a x equal to square root of a square minus y square cos theta. Then dx equal to square root of a square minus y square constant minus sine theta d theta. If that is the case, then dx now I can replace with square root of a square minus y square minus cos theta d theta. Here a by something. A I can take it out. 1 by square root of a square minus y square minus x square. X I can substitute as a square root of a square minus y square cos theta. If I settle it down, then a square root of a square minus y square would come out. Now it will be 1 by square root of a square minus y square root of 1 minus cos square theta. A is outside. Now it becomes 1 by square root of a square minus y square sine theta, where numerator is square root of a square minus y square minus sine theta d theta. Sine theta gone. Square root of a square minus y square gone. Minus minus d theta. Minus I can take outside minus a integration of y minus a to a integration of x minus a to a, and now minus now d theta dy. Now what is theta? Now if this is hemisphere I am taking, and x is from minus a to a, means theta is pi, theta is minus pi to 0. If x is minus a to a, then theta I am taking the angle that is pi to 0. Okay, if that is the case, then because we have taken down in polar coordinate, if x equal to square root of a square minus y square, that is considered as radius. So x equal to square root of a square minus y square cos theta, a cos theta. So this is a polar coordinate. If it is polar coordinate, similar, right? Now d theta integration is theta, d theta integration is theta, then from pi to 0. Okay, then pi to 0 becomes minus pi. Minus a is outside. Now it is pi a. Pi a dy. Pi a dy. Pi a dy integration is y minus a to a 2a. Now it becomes 2 pi a square. We calculated for the upper hemisphere, then full volume is full surface is multiplied by 2, 4 pi a square. Okay, so the surface area of a sphere is 4 pi a square. Unknowingly, knowingly, we calculated the surface area of a sphere. We can calculate the surface area of the sphere through full-fledged polar coordinate also. This was through Cartesian coordinate. So polar coordinate if I take, polar coordinate if I take, then now I have a by square root of a square minus x square minus y square dA. If it is Cartesian coordinate, then dA, dxy plane is dx dy. If it is polar coordinate or cylindrical coordinate, then dA is r d theta dr, r d theta dr. So a by square root of a square minus x square minus y square r d theta dr. Now x equal to r cos theta, y equal to r sin theta. Now it will land up in a by square root of a square minus r square cos theta minus r square sin theta. Net if I settle down, a by square root of a square minus r square r cos r d theta dr. A I can keep outside. Now it is integration for the surface. If I take integration of the surface, then I have taken polar coordinate. So integration polar coordinate means along the xy plane. Then r is 0 to a and theta is 0 to 2 pi. That is the integration. Now a I have kept outside, 1 by square root of a square minus r square r dr d theta. R dr d theta. If that is the case, then r by square root of a square minus r square, what is the integration? I believe it will be minus square root of a square minus r square, because if I differentiate, then it will become minus r divided by square root of a square minus r square. Minus gone. So the integration of r by square root of a square minus r square is minus square root of a square minus r square dr d theta. Okay, I mean dr integration is done. Now r is 0 to a. If I place a, it becomes 0. If I place 0, then it becomes a. Okay, and I believe 1a is outside, so it becomes a square. Okay, so a, the integration of r is 0 to a, so 0 is the lower limit, it brings minus, so minus minus cut down and it becomes a square. Okay, so it becomes a square. Now d theta integration is theta to 0 to 2 pi, 2 pi 2 pi a square, that is for top hemisphere, because we converted Cartesian to polar coordinate. Full is 4 pi a square. So we have done lot of permutation combination calculating the surface area. Please watch that video chain. Calculating the surface area we have done in Cartesian coordinate, we have done in cylindrical coordinate, we have done in polar coordinate, then we have done in kind of interchangeability, interoperability also. Every permutation combination we have done the surface area. One or two I'll try, and then we will proceed in the flux calculation for the spherical coordinate and cylindrical coordinate, that we will see. Amazing, right? So calculus, you are amazing, because algebra, you are amazing. So main power of the calculus is algebra, because algebra is a function over independent variable, and if I keep changing independent variable, then values keep changing. So infinitesimal small values are also taken care. So that we will see.